For the class for robotics, today I will go through the whole introduction. Actually, every textbook or every course for the introduction part will be more comprehensive or more completely. In other words, so sometimes we as a teacher will take an exam from the chapter 1, but it's unfair. Yeah, because the chapter 1 will overall review the whole text. However, it only touch the very slightly the service of the technology or the content we want to deliver. So, for example, I teach the fluid dynamics before in our department, and for the chapter 1, I always skip it. Yeah, because the overall introduction is okay, but when it go to more detail, the students get confused. So for this one, I just want you lay back, yeah, because it's not so serious today. You can lay back and enjoy the class. But I will have some question, give it to you. Maybe you can have some feedback to me, because I will prepare some paper for you to write. Okay. For example, for the morning call. What is morning call? Because everyone just wake up from the warm bed. Today is the coldest day, maybe in this month. And it's weird, yeah, in Kaohsiung I never feel this kind of cold before. Since 20 years until now, 20 years, I think more than 20 years. Yeah, I don't have this memory. The Kaohsiung will down to this cold. So the morning call is wake you up, just in case you still get fuzzy, did not sleep well, or hangover, something like that. So the first 4 questions I would like to give it to you will be actually 3. These 3. Before you attend this class, I think you have some expectation. But what is that? Or you may want to understand or touch a little bit through a formal class. What is the robotics? So the robotics to everyone's definition will be completely different. For a kids, I think the definition will be more complicated, I would say. Because a kid always think the robot is something like a 无敌铁金刚. They can do everything they want, and they can eliminate the enemy in 1 second, something like that. Of course, their imagination is so enormous. Yeah, when you was a kid, I would say. Yeah, because I still think about what was I think when I was a kid. Yes. So in your mind, what is the robot can do for you? Okay. And will you expect that they can do more? And why is that? So the first question is, according to your knowledge, what can they do? If you did not have any sense for that, I would say sometimes for the selected class is a little bit difficult for you, because you don't have the enthusiastic. Enthusiastic means 热忱 for this field. Then you attend this class. Of course, you don't take it more seriously. But if you have some goal in your mind, maybe you will take this class more seriously, because you know how large is the impact to you for this kind of field. Of course, in Taiwan, the semiconductor manufacturer seems occupied a very large portion, especially for your career in the future. Especially we have, I think it's the other side. There are so many factories. They are supported company to the TSMC. So you will find a lot of job over there, but it's manufactured. and is TSM, is a semiconductor manufacturer. Do you know what does that mean? It means you are a very high-end worker. You are never be named engineer. You know what I mean? Engineer and the worker is a little bit different. I would say is a big difference. So manufacturer, I always, I heard from my advisor, let's say he said, okay, the semiconductor manufacturer is manufacturer, of course they need a worker, okay, not engineer. What is engineer do? Engineer do design, do analysis. Of course they do some manufacture for validation. But it's different. When you work in TSMC, most of you will work as a manufacturer task. Will do the manufacturer task, okay? So it's quite different, I would say. So come back to the robot. I would say this is another industry, not new industry, I would say. But it's a very attractive industry to me, actually. I think one of the reasons I studied mechanical engineering for more than 10 years is I was attracted by this kind of stuff, like robotic, like a vehicle, like a weapon, something like that. So I never fascinated to the IC because I think IC is, oh, I just purchased the IC and use it. I never think, oh, I want to devote myself into the kind of IC design because that is not my interest. So I always think about how can I use the very strong computing power IC to do whatever I want. And this is one of them. Right now the combustion engine, like a gasoline vehicle, is said to will be eliminated after maybe 2035 or maybe 2040. No matter how far is that, you will face that because people will ask you or the government will require you to replace your car. So a lot of students already ride an electric motorcycle. That's a good sign, but that's a different thinking. For the commercial view of that, have you noticed something different? Okay, because we are not a car manufacturer country, so maybe you will not notice the difference. Because like a Korean, Japan, United States, and Europe, some country, they manufacture a lot of vehicle. Vehicle is car, okay. And because we did not manufacture a lot of car, so you cannot feel the difference. But I noticed that after they are pursuing the electrical car, they call EV car, okay. A lot of companies show up. It seems a lot of companies can manufacture the EV. But how come when a combustion engine age, not a lot of people can manufacture the car? Have you think about this? Okay, this is the question. Sometimes I get bored, so I just think about this kind of question. It's a good one. I have a conclusion, but I will leave you some space to think. Okay, so in a morning break, not a morning break, the morning call, I will ask you to do these 3 questions. Write on your paper. I think you don't have any. Okay, I'm not sure what is your answer, but there is no correct answer. Yeah, I will say. But at this point, because you can review your response, then you may think about what is the technology need to be applied onto a robotic system. Like a vehicle, like a motorcycle, like a cell phone. They are all very complicated system, even for the robot. So I'm not sure your answer, but I can guess it's something maybe unreachable. This means it's like a human being. They can think, they can do what they want or what they think they should do, something like that. So over here, I just want to have some demonstration first, then we come back for the conclusion. When you think about a robotic company, I believe your thinking and mine will be different. Because I'm in the previous age, we all think about the robotic. What is a robotic company? A company which can be built, can survive because they have products. So if they just produce one, for example, there's I forgot the name, you can take a look. There's a Japanese professor. He built up a robot very similar to himself. So sometimes if he is not available, he don't have time, he can send his robot to the conference to do the presentation for him. It's odd, but it's a kind of interesting topic in my age. And there's a complicated one, but a simple one is we call the robot is robot arm. The robot arm is like a human arm. They can perform some tasks like a human. But I think I can imagine that the robot definition in your age will be different. Could you name some robotic company for me first? Any? Sangyin. Okay. High Wing is a robotic arm. Okay. So you are in my age. Okay. But it's okay. 等一下找我登记。Huh? Kuka. Robotic arm in my age. Okay. Any other? 东元 is a kind of component supplier. Okay, component supplier. Okay, but you mentioned something important because robot is a system, as I mentioned, and Dongyuan provide motor is a critical actuator for robot. Yes, it's good one. It's good one. Any other? Fanak, robot arm. Yes. Yes. Tesla. This is the company in your age. Okay. Any other like a Tesla? Not the car, the robot. That is a very important company. I noticed it for a long time, but it seems not very popular because it did not mass production their robot. But a lot of people mimic. They try to learn from them to do the robot, to manufacture, design the robot. Okay, have you heard this company before? It will be very important company, but it's a weird company. When I say weird, is I believe it is belongs to the military section, but this is the first one to produce the human-like robot and the robotic dog to carry something. So if you did not realize what's going on for this robot, I will suggest you to take a look for his website. Over here, I don't want to show too much, but there are some I think I should do. Maybe this you have an idea what is the company do. I think that this is the first company I have ever seen. They have a two-leg working robot. This one is, I'm not sure it's okay, but oh yeah, it can. It jump. It start to jump, and they can flit. Oh, he's dancing. Okay. What is the stuff in his backpack? Can you guess what is that? Backpack. Okay, I don't want you to see this dancing too much because this one is better. Okay, you can watch more at home. So by compared to the Tesla, they call Optimus, maybe you will find out the Tesla may not so different, but it is. There are so many different, but the more detailed part, I will leave to the end or in the middle of the class, then we can share, okay? So the robotic I may expect in your age is maybe you will come out so such kind of robotics because it's human-like, but it can perform the running, jogging, maybe fighting, or do the whatever you do in the factory. So when I say worker, as an engineer or worker is different. As a worker, the robotic already try to replace most of the task. But for the engineer part, they still need a human. Okay, so I believe before you graduate, some professor, including the Professor Liu Dongguan, and including myself, I will teach you how to use the AI tool in the class. And I think this is a trend because we cannot stop the trend if it is good for your performance or output. Okay, so this is the future, and maybe it's not too far away. Okay, so for the robotics, we just, or you have already wrote, what kind of, maybe you have an idea, the department, you know the department, right? Like electrical engineering, mechanical engineering, mechatronics, or civil engineering, like something like that, because it includes every kind of technology we need for the whole country. For the robotics, what do you think they combine with what kind of department or technology? What do you think? 刚刚讲过就不要了哈，等一下来找我哈。Okay. Others? What kind of technology they included in the robotic? 旁边那个同学准备一下。Yeah. It's easy, right? Name it. Or you don't understand my question? What is my question? What is my question? Robot 用到哪些科技？是我们跟我们的 department 有关。我是讲的是所有的 department。你知道 department 吗？你当然可以讲技术。Vision. How about the other? Technology including everything.
Waiver.
Huh?
Waiver.
Waiver?
Yeah.
What do you mean by waiver? Do you know what is waiver? Wafer is a pizza, right? It's just the nut. Okay. But without any topping, it's a nut. Do you know what I mean? I always make fun of the wafer. Don't worry about it. Later on. Okay, what is that? Sensor. Sensor includes everything. So yes, sensing technology. Okay. Revise a little bit. Your answer will be more approach to the robotic. Wafer is like ceramic. Steel. Aluminum. Wafer is something like that. Of course, you can melt, but wafer cannot. I am saying that aluminum or steel can made for robot. No, it's made by, okay, made for robot. Okay, any other? Control is knowledge. Yes, control. Of course, control. Control. You can think about what have you learned in our department or other department. Then you will combine a lot together. So far, you did not mention about the structure. Do we need a structure?
Mechanism.
What kind of mechanism? Could you name more specific mechanism? Mechanism in our translation maybe is right, but for the structure, yes, mechanism. Okay, but we need some connection, others, and you guys did not mention a very crucial part. What's the crucial part? Yes. Power transmission still mechanism, but it's okay. Power transmission in my SSL. Okay. You know, power transmission is a mechanical component. You understand, right? Okay. Power transmission. How about power? Nobody mentioned about power. Okay, so I name it power. Power is kind of wide, so we call it actuator. Actuators. Actuator includes everything because right now not only the motor can drive the robot. There are some linear motor, linear screw can drive the motor also. So I will sum it as an actuator. So the backpack, the robot you just saw, is interesting. The guys can succeed so, I would say, can come out of products more quicker than other people is they carry an engine on the backpack. They use the engine to power the whole robotic. This is a different thinking. So you cannot maybe criticize the American guy is so ego or something like that. In that area, there are some very smart people that dare to think and dare to do something different from other countries, I would say. Okay, so yeah, that's what I want to share with you. Okay, chip, the wafer. The wafer's proper description should be the maybe IC. Yeah, because wafer is the nut. Do you know what is nut? 面饼. Okay, but you need to have some topping. Topping is called the pizza need a topping. Then you can feel, you can have a flavor, right? So it's called IC, of course IC. So IC is important, but you can find out from this list. It's just a part of the component. But without the others, the robot seems not so well to be accepted by the human being. Okay, if you want to have some raker, yeah, this can be your raker. Because in this age, I think AI is very important. Okay, even though I'm the mechanical guy before, but robotics is another trend. Because robotics is more close to our department, mechanics. Because we have almost everything, or including the material. We have almost everything class. Maybe it's not so deep, but you can have the preliminary understand. Then when you go to the interview for the robotic company, at least you can say something. But of course, the control, they always ask our students can do the control part. Yeah, because we are expected to have the better control background than other like a department, other department. So I would say this is what you are expect to. Okay, good for everyone. Okay, for this class, I would say most of people may think it's a little bit different because we have a big dream. The robot can walk, can recognize everything, and can grasp apple and egg with one hand. This is our human. Actually, we are trying to make a system very like our human being. But in our class, we are just the first class, I would say the first class for the robotics. So you were a little bit disappointed. But we have to do that because without this kind of fundamental knowledge, you cannot step to the next stage. So I would say, okay, so be patient and maybe you can solidate your foundation for your research later on. And for example, in our laboratory, this year is weird because since last year, a lot of people assign us to build up the robotic system. And we have already produced, we count for 3. Yeah, we already have 3 systems. So basically, we need to apply some, we need to integrate some technology on that, but start from the fundamental part. Okay, for the introduction, this is the list. I don't want to go to more detail because it's a more fun part for that. Robot named from long time ago. So if you watch a movie before, I like watching movie, and I would suggest you do, because watching movie can explore your creativity. Yeah, some people agree with me, and I grew up in the movie age, so I love to watch movie, and I think this is one of the movie. Yeah, before the mechanical design or called mechanism designer, previously are quite popular in the age. The age is before maybe 19th century, before 19th century or between. Because you can, I always think about one thing, but the thing is not good one. That is, okay, in World War II, there are some competition between the United States and Germany, if you know the history. But you know the weapon between these two countries is so different, because from the kind of design you can figure out the European people did the good job for their mechanical design. So their weapon is so light, it's so, I would say so dedicated. Dedicated means 精密, dedicated. So they can perform very well performance, but with a human can carry it, lightweight style. So that's quite different because the United States manufacturer is used a very thicker steel to do something weapon, and they can perform okay, but they are so heavy to carry on. So for a long time, and later on, I joined the E3, is the first workspace I have in Taiwan. I have the contact with some company. The company manufacture the packaging machine. The packaging machine is not for IC, it's for the medicine. Maybe you think, what is the low tech? Okay, so the medicine, you go to the doctor, they give you they call tab, right? The tab is sealed inside a very delicate, I would say, packaging. So when you push it up, okay, you can get one tab, then you take it. The other can be preserved in room temperature without any problem. The packaging speed is so quick. So the the machine I have ever seen is around maybe 600 pack per minute, something like that. It's so quick, and it's manufactured in Italy. Italy? Italy is a country so romantic, right? But when you think about it, in the previous age, I don't remember how can I pronounce that. It's Renaissance. Renaissance is 文艺复兴. Renaissance age, the Italian area have a lot of great texture or statures and some kind of great drawing or pictures, not picture drawings. But the kind of so romantic country, eventually he invented a very good sport car. Which one? Ferrari. And
Alfa Romeo.
it's okay one. And then the other? Lamborghini. It's weird. It's so romantic country. How come they can invent this kind of so fancy car? And the performance is quite well. So you may figure out, oh, what's going on? This kind of romantic country and people, how come they can come out with this so complicated system? Okay, so around the time the robotics is come from there, but it's weird, it's from Czech. Czech is 捷克, it's Czech. So it's a little bit different. So the definition, we can skip that part because it's the old school part. And if you want to try to find something else, right now it's so easy. Yeah, because you have a Google, you have ChatGPT, you have a Copilot. So just feel free to do that. And if you want to go to the United States for your further education, Carnegie Mellon is one of the very popular university in United States to pursue the robotic design. So this is one, but not necessarily the computer science. I would say the whole university, I think they devote to the very novel technology, including the robot, mechanical, computer science, and EE. Yeah, so if you have one, but it's very difficult to apply. I did not apply it, yeah, because it's still so difficult to me. Okay. Okay. This is some suggestion. I forgot what's for something, but it's okay. Watch for my PowerPoint will be fine. Okay. Oh, you are encouraged to purchase the book. I think I bring you the book, but not everyone interested about the part. But if your thesis is related to this field, I would suggest you to do that, to at least purchase one textbook at hand. And the textbook should include the derivation for the inverse and forward kinematics will be better. Okay. So as I mentioned, I did not touch the very complicated robot in class in the lecture. The reason is we need to start from the fundamental. And the very fundamental for the robot is we need to define the position. We need to define the position for each joint. So I remember one student come back to me for other class. He said, should we really need to use the global coordinate and reference coordinates? Okay, this is a very decent question, I would say. Okay, so what is his question is, do we really need to, we need a lot of coordinate to describe a system? Do you know what I mean? Until right now, have you ever faced other system needed two coordinates to describe? I think it's rare. Maybe some of them already faced. So at this point, okay, then I need my pen. So for the next part, as I mentioned, we need our mathematical model to describe the position for each arm, because we have a multi-degree of freedom. Like a CNC, if you treat a CNC as an example, CNC can be treated as one kind of a robot also, because you have at least XYZ degree of freedom. And some very high-end one, even they have a 5 axis. The 5 axis, they have a 5 degree of freedom. So it depends on the degree of freedom. I can define over here is if you have a 5 degree of freedom, maybe you need a 5 reference coordinates to describe the whole system. When I say describe the whole system is we exactly want to know where did it go. So if the arm can reach to somewhere and I need to know what is the angle of the motor and what is the position of the motor, I need to rotate, then it can reach the end point. Okay, so the mathematical model will be the major point for this class. And for the first part, they call robotic manipulation. But for the dynamic aspect of manipulation, maybe we will not touch over here, but it's quite important also. Because you already see the video I just show you for the Boston Dynamic, and also the Tesla did not show too much, but you also have. Especially for the Boston Dynamic, I think this company have quite aim to the target is everything is dynamic. Yes, because if you go back to the original, okay, that's a long story, but I can share with you is the robotic business in Taiwan is not so successful. The reason is we have so many quite good products from Japan and like KUKA from Germany. And when we try to develop ours, like a high wing or Sangyin, but eventually the price is not, cannot compete with other foreigner products. So I think that Boston Dynamics also think the same, because there are not so many famous United States robotic arm company. So they try to use different thinking, like they produce some kind of human-like robot or working robot, yeah, for some industry. Maybe it's not quite into our commercial market, but eventually they already have some spatial usage for their product. So I think they survive. They survive very well. This company already exists. I think it come out at least 10 years, because when I joined E3, I think the company just start up. Okay, and also our students just mentioned the robot need sensors available in modern robotic system. One of the company in Taiwan, they also proposed this kind of idea, I think 6 years ago. It's called Damin. When the Damin come out, the standard outfit for the robot is every robot arm has one eye in hand. So I think it's quite a novel. I never saw the company do that before and after. Maybe the integration is our strength, I would say. The integration in Taiwan is our strength. We can integrate vision system with rubber arm and other sensors without any problem. Especially we can acquire the kind of sensors easily. Yeah, we can go to Taobao, although Taobao is China, but other like a mouser. I like a mouser. Yeah, you can purchase everything as long as you know how to integrate it. So I will say for the Taiwanese engineer, I will encourage you to do something like that. It will be more interest. Maybe the money is not so much, yeah, but I would say it's interest. You can do it for a long time, okay? And later on, I will try to touch the part this semester for the planning. Yeah, because the students mentioned I did not teach the planning, but the planning is quite interest. And also, as I did not mention last week, but I will. Later on, yeah, I think I mentioned it. You will perform the robot language to plan your trajectory for 2 types of robot. So the planning maybe is not exactly what you do in the practical practice. But the planning is inside the computer, the robot computer, because when you, I can give you a roughly example. If you want to go to A point to B point, as you input, you just mention the A point and B point. But the robot will not go directly to that, because sometimes limited by the motor limitation, because when you rotate, the robot is rotate, right? But the arm cannot, it's very difficult for a robot to go straight line. So tell you the truth, there are so many limitations, but one of them is the robot is there to go straight line. Straight line is very difficult to a robot. Yeah, if you know the design or everything, except the kind of part they call SCARA. SCARA type of robot is for the electronics assembly in purpose. Around the time they come out, this kind of robot is for, yes, I need to go straight line, but the other types cannot, so they produce another type. But normally our arm, if you use your arm to go straight line, I believe it is a little bit difficult. When you go start from A to point, this is a straight line, no, this is a curve, right? Okay, so if you can understand that, then it will be easier. So when you go to A to B, the planning will be plan a route. This route will be smooth for the robot to operate. So it will not go straight line directly. So sometimes if you want to do the planning, they will planning inside. So if you can roll some algorithm, for example, we have we designed a trajectory with a very simplified polynomial, and the polynomial have a different orders, right? So if you have a high orders, then can go more. I will not say smooth. I cannot misguiding you guys thinking. But proper orders can lead the robot go smoothly. Okay, so I am planning maybe I should go to this part in this semester. Okay. And also basic idea for, okay, they will be all. Okay, so the symbolic representation for robot is good to know. Yeah, it's, so I would say today is very casual. So there are only two types of joint. If you can invent another, they will be new. Okay, the very popular one they call revolute joint is the rotation one. Let me show you the figures. So the revolute is like a motor, rotating motor, because the motor have a linear motor also, rotating motor. And because you need to draw the line, or draw the concept line. So as an engineer, you only draw the concept line. That's the reason when I graduated from NCKU, I cannot read a manufacturer diagram. It's difficult to me because I have no idea what's going on. But I can draw this line. I can do the calculation. I can know how heavy I can use for the robot, for the motor. So what kind of motor and the transducer I need to use. But I don't know how to do the manufacture. Okay. For the 3D part, yeah, we draw by this way. So they have a concept. Okay, this is a 3D revolute joint. Prismatic, as I mentioned, the prismatic have a very special joint. It's a rollerball scooter. Okay, 滚珠螺杆, rollerball scooter. Rollerball scooter, they can do the very straight light path. So they have a special usage. So the prismatic is they can draw by this way, but I think it's too complicated for 2D. Okay, but for the 3D one, okay, we will use this a lot. Yeah, for the 3D one, yeah, we use the shape, the cartoon diagram to represent a prismatic joint. Okay, so I would say over here is so very fundamental one, very okay. Configuration space. I think this part is I don't want to confuse you, because we don't use XYZ anymore. Yeah, in dynamics study, if you go to a reading and you instantly you find out there is no XYZ anymore, then you are in a success way. Yeah, because XYZ is too narrow to describe our system anymore. So we use this code, they did not mention that, but it's called generalized coordinate, Q. We use a Q to define our degree of freedom. Okay, so when we have like a Q1 to Qn, it means we have a n degree of freedom. Okay, so in that case, we can solve this kind of system without this is which x or which y. But in the future, we still use the very common one. But you need to understand, if we go to the very dynamic way, then the degree of freedom is not necessary only XYZ, because we have a rotation XYZ. Then it's very difficult to describe. So because in space we have a 6 degree of freedom. Agree? X, Y, Z. Rotation X, rotation Y, rotation Z. But it's 2000. So we use Q1 to Q6 to represent whatever I said before. So it's easy. But this is said, this coordinate use Q1 to Q6. The next one will use Q7 to Q12. Then you can have a lot of coordinate. So you need to learn something about coding. So in this class, I will use MATLAB to do the matrix operation. So if you don't quite understand the MATLAB, that's pretty okay, because the content I teach is so fundamental, so you will understand. Okay, and as I mentioned one more time, before you graduate, you need to know how to do the programming. Then I think I added another one, right? Before you graduate, you need to know how to use Copilot or ChatGPT, or you will doom. Okay, so remember this. Okay, configuration space. Okay. I remember I upload chapter 2 for you, right? Okay, good. Read through the whole part. Yeah, next week we will touch that. And for the chapter 1, I think if you are thinking it's necessary, I can upload also, but it's only for the introduction and practice your English also. Okay. So, okay, mentioned here. Okay, so we have an n degree of freedom. Yeah, I to n is the degree of freedom. And it's a configuration. Then it's equal to the, okay, let me take a look. Okay. A rigid object for 3-dimensional space. Okay. And as I mentioned, X, Y, Z, and the rotation X, Y, rotation Z, we define it as I label with the blue color. It's a 3 for positioning and the 3 for orientation. Okay, 3 for positioning and 3 for rotation. Rotation means orientation. So I provide the PowerPoint last week. There are so many vocabulary. Yeah, the vocabulary is something we will use in this textbook. To study engineering is easy for English, I can tell you, because the vocabulary is the same. Okay, I remember when I studied the MBA, it's a business school. The sentence, they use a double line sense to describe one thing. This is a nightmare for me around the time. But they don't have something to show off, so they just show off the grammar for the English, I'm thinking. Okay, so until this point, okay, So positioning, orientation, 3 for each. Okay. So over here, I also defined if your robot is less than 6 degrees of freedom, it means there are some degree of freedom you cannot reach. For example, if my robot have a 5 degree of freedom or 3 degree of freedom, there are some degree of freedom I cannot perform. Okay, so you need to understand this definition. So how is our arm? How many degree of freedom of our arm? Can you define it? Question? Any? No question? Answer? I preserve the answer. Any others? This is a trick question because I did not mention the part yet. So I just let you think. The cobot, C-O-B-O-T. Okay, yeah. Cobot is the robot can cooperate with people, but the definition is they can cooperate with human without a fence. Or fence is 隔离. Because without a fence, it may suddenly perform some unexpected motion, then will harm the human being. So this type of robot have a very strict regulation and design, just in case. I believe I have some video. Let me take a look if I have some. This is a very traditional one, and the special name for this one is called articular. Articular is 关节, articular. Articular manipulate. When they say RRR, it means, I forgot it's the last or first 3 revolutes. Is the joint, the joint is a revolute joint, okay. And they also have a special design for high payload. So why the European company come out the robot so quickly is one of them is they want to keep the car manufacturer industry in European, also in United States, and so they can make it in EU or made in USA. But the worker is very difficult to lift something heavier. So they adapted the robot to replace the worker for this part. So that's why in the beginning the robot is growing so quickly in Western countries. Okay, and because we don't have too many car manufacturer business, so we don't care about that. So in the future you will see a lot of this kind of simple diagram. The simple diagram over there will be the first 3, I believe is the first 3. The first 3 joint, okay, the upper over there, the body, and they are revolutes, so they call RRR, so it's the first 3 arm. And the working space, as I mentioned, they were not straight all the way. They will curve a little bit, and the working space can be defined. Okay, so we have a forward kinematics. Maybe it's not so useful, but when you want to estimate the working space, the forward kinematics can help. This one is a very special type they call RRP. Okay, I think I just mentioned it will be fine because they don't exist anymore. So it's an ancient antique. Okay, this is the SCARA I just mentioned. SCARA is abbreviation for several words, and I don't want to repeat it again. But it's quite popular. It is quite popular. I think it's for its price. It's so cheaper. Although it has a 4 degree of freedom, but the last degree of freedom is prismatic, not prismatic, prismatic, 线性的 prismatic. Okay, so in some electric assembly task, it can perform very well and very accurate. Yeah, okay, and also it's cheap. Okay, easy to manufacture. Okay. This is antique, 古董了哈。Okay, I don't want to touch it. Okay, this is quite accepted for all of our Taiwanese integration company because it almost don't have mathematical model. You don't need. Yeah, it's just they call. I usually call it XYZ table, XY table, something like that. But they have a special English term. It's called Cartesian. Cartesian manipulate. So they integrate three motor. If you have three motor, you have a 3 degree of freedom. Then you can go. In this case, it is only for SY table or SY. So it's easy and easy to integrate, and also I'm not sure cheap. But they have a very big drawback. Is it occupied a lot of space because the whole screw drive will go through the whole stage, and if you need a Y in axis, you need a huge stage to lift it up. So that's a reason in some case, or in the modern electric or mechanical integration, they already replaced this kind of machine. But this machine is very accurate, I need to say. Yeah, because in articulate robot, the drawback, the good thing is they are so flexible, but the best thing, the drawback is they are not accurate, not enough to do some task. And I'm not sure how can I translate it. 插件机有听过吗? Okay, or 插线机. If you have an IC, you need a wire bond. You need a wire bond. When you see a video, you'll see it's so quick. This is one type of the robot. And the kind of robot will use Cartesian. Yeah, because the Cartesian can be very accurate. Could be very high speed. Okay. And I did not think, I don't think I mentioned that for this class is called 曝光机嘛. Okay. Okay. 曝光机, yes, I think they use the Cartesian manipulator also. Okay. This is a very special type. I like this one a lot in my laboratory, and in this semester you will use one of them. I'm not exactly have this kind of shape, but this called parallel manipulator has its advantage because it can move very fast, very fast, and it's very cheap also. Okay, so because they have a sling arm, and the sling arm will lift very lightweight payload, but when I say lightweight, it's up to 1 kilogram, so it should be okay. So when I say food industry, 夹寿司, food industry, they use this kind of display into the bentong. Okay, I think in Japan they always do that. Okay, so it's quite popular for the food industry. Okay, and this is one of the application. I think I want to show over here is in this case it's like a grinding. If you know about grinding, you can they always mimic the human hand, not arm only, hand. They will try to use the human arm to mimic the human hand. Okay, grinding. What is grinding? Grinding is 研磨. Yeah, when you manufacture the product with casting. Casting 是什么? 铸造. When you casting out, then there are so many burr. How can you deburr? Burr 是毛边. Deburr 去毛边. How can you deburr? Then you need a sander. The sander can grind it out. However, when you do the sanding, grinding motion, you need to control your touch. I would say feedback force or touch distance. Eventually the distance, and you need to feel the force because you don't know the distance. So you can only feel the force. But the robot don't have either. Robot can only have robot have a position, but robot don't have any force feeling. So in that case, you need to adapt to the force sensor onto the robot system. However, the force sensor is so expensive, so sometimes it is not feasible. But before it's not feasible, maybe in the future will be. So for the technology in development, it should be okay. But in other case, they can use the camera or the CCD to guide the robot to go through the whole process. You know, the Hanxiang have a very similar team to do that, and they are all recruit our students. 我们有一个汉翔专班哦，后来有5个吧，哥俩好，3个还5个，最后全部都是在他们的这种部门，帮他们开发 grinding 的一个machine 怎么去调整OK. I think a lot of industry want to transform. Not only transform, maybe in sometimes they need to do something attract high-end people. For example, if they recruit our students is 专班, right? They need to go to Hanxiang. I think almost 30 people, but stay in the company only not more than 5. But how can they attract the 5 people stay in Hanxiang? They have formed a new group, the automation group for them. Okay, so they can do whatever they need for the company, but it's very close their study in the university. So I would say this is the transformation for future. Let's turn. I just noticed that n effector. What is n effector? There's a robot, okay, but robot don't have the finger, we call gripper, but the special term called n effector. So the n effector is the end. We do whatever we want. So they can have a gripper, clipper, or suction, everything. They call n effector. So this is the special term you need to know. Okay, so I think it's a go through the whole session I want to touch. So in the next week we will go to the rigid motion. Before I spend some time on that, but it seems okay to you guys because you guys are so experienced for the engineering session. So I should go a little bit further, for that. So the rigid motion, we will see. Okay, maybe we will not touch too much, then we can go to the next level. If you want to prepare something, maybe, I already distribute the material to you. And the mathematics we will use is a vector, only vectors, not matrix operation yet. Okay, so vectors, I will suggest you at least have a preliminary understand. But after engineering mathematics, I think you guys are okay, so should be fine. Then I will touch the forward kinematics. Okay, so maybe I can go directly to the forward kinematics, will be easier. I don't spend time too much in the chapter 2, maybe very good. And forward kinematics, and I will explain a little bit about the cross and dots, the vector, then how come we come out the transformation matrix, okay, and how is the transform matrix we will use later after, okay. And you see, I explained the dot and the product better before. I think it's insulting you guys. Don't do that. You should review by yourself. I think you will catch it up. Okay. And okay. Then we'll go to, before we, I think, forward. I think forward, we already touched that in forward kinematics. Then we will introduce a very, very important denominated Hartenberg convention. It's long, but abbreviation is called DH form. The DH form is, they have its assumption, and if you meet this assumption, then the DH form can use directly. Okay, as I mentioned, we need derive the robot for 6 degrees of freedom. However, in the DH form, we only use 4 degrees of freedom, can describe it out. If you design the robot, follow the assumption, then you use the DH form to derive your transformation matrix. It will be easier. Okay, this is quite important. And the velocity kinematics, I think it is related to Jacobian matrix. I did not touch the part before, but we will see this week, this semester. Okay, we'll see. Because Jacobian is used for our trajectory planning. So maybe it's a good one to introduce a little bit. Okay. And more matrix performance operation over here. And yeah, you see, I can always have a lot of notes and explain to you. So it's quite exciting, huh? Inverse kinematics. This is the very important part that we need to describe. And after we finish the inverse kinematics, eventually you are a basic qualified, that's why I'm saying, qualified robotic engineer. Yeah, because at least you can know how to derive the inverse kinematics. Forward kinematics is easy, but inverse kinematics is quite a little bit challenging. But yeah, we have a tool to help us. So learn the tool by yourself, then you will be fine. Okay, and pretty much, if I can touch further, I will go to the path planning part, because I think this session is more benefit to you in the future. At least you have some, especially in the future, we have not any effective clip. We have 5 fingers. 5 fingers. How can you recognize the position in the space? Before the arm, we have 1 DH form. How about the finger and the grippers? So it will become more complicated. Okay, so we must have some solution for that. Okay, so before we step into the session, we need to figure out. But the teaching session, I think path planning can help. Okay. This part we will not touch that because it will independent joint control. Yeah, it will a little bit different. Okay. So the dynamics something independent control, nonlinear force control, vision-based control. We will not touch that. But we will actually, vision control to me is not so different from inverse kinematics. I would say the vision recognition will be more difficult and need to learn for you in the future. What should I say for the vision? I forgot it. Force control is a more difficult topic. I think it can take a full month to describe that. Okay, so each of them are good, but big topic. Okay, so we will not touch it in this class. Okay, then this is the work for next week, and I think it's the same. So I will leave this to you. If you don't know how to use MATLAB, practice a little bit, because you need to know how to do your homework. Not homework, in classwork. I don't have homework. In classwork, in the classroom. After you finish the in classwork, then you can leave. So if you don't familiar with that, try. Why I use MATLAB, not Python? Because I believe this one will be easy for you if you need a file resource. But Python is really a good coding program you need to learn. So if you can learn both, it will be fine. So I will have some practice for you. Single link, forward kinematics, and the inverse kinematics maybe next week or the next 2 weeks. So it's okay. But if you don't know how to use, but our computer already installed the software, so don't worry about that. If you want to use your computer, it's welcome too also. This is the diagram I will attach. So this file, I believe before I upload to the internet, not internet, our class network. So if you need, you can feel free to download. Should be fine because I revised a little bit.